All right, welcome everyone. We'll get started here with today's upskill workshop. So welcome. My name is Valerie Elliott. I'm the director of the WiDS Datathon program. And today I have with me my colleagues Sharda and Maggie.
Thank you, Valerie. Good morning, everyone. My name is Sharda Kalanidhi. I'm technical director of the WiDS Datathon, and I have had the privilege of being involved in the Datathon, particularly in the dataset preparation for many years. So I'm always super excited to meet the winners and hear the solutions.
Great. And this is Maggie Demkin. I'm from the Kaggle team and have been working on the Datathon for 7 years now, along with the rest of Kaggle. So I'm excited to hear your solutions and congratulations.
Yeah, wonderful. So this year in the WiDS Datathon challenge number 1, our participants analyzed a data set that was provided by Gilead Sciences focused on oncology. And it was a really great challenge. We had a lot of first timers who have never done the Datathon or challenges before. And we also had a lot of beginners that were participating from all around the globe. So today we have the pleasure of hearing from each of the 6 winning teams from the challenge. And we will be bringing on one representative from each team who will take about 10 minutes to share their team findings and results and learnings during the competition. And then we will follow each of the presentations with a Q&A led by Sharda. So if you have any questions for the teams, please post them in the chat. The rest of their teammates are also dialing in right now and will be available in the chat to answer your questions. So we're going to kick this off. And first up, we have the top student team. So this is team Drop ID PSUT. Their team is from Amman, Jordan. And Rama Bashar will be presenting on behalf of the team. So I'll bring up Rama and hand over to you to tell us all about your solutions.
Thank you. Hi, my name is Rama. We are the top student team that won in the WiDS Datathon. My teammates are Reem, Kareem, and Nasser. And we managed to get 9th place and top student team. So basically, a background about us. We are second-year students. We study in Princess Sumaya University for Technology, and we are majoring in data science and AI. We really had no past experiences in really big competitions like WiDS, but we had some small competitions from our university clubs, and we managed to get some experience from them before going into WiDS and its Datathon. So first, for a basic summary of what we've done, first and foremost, the first things were the columns that we found most important in the competition or the data that we were given were the breast cancer diagnosis code, the metastatic cancer diagnosis code, the patient ZIP3, patient age type, payer type, patient state, and breast cancer diagnosis description. We also used CatBoost, XGBoost, LGBM, and logistic regression in order to make our model for this data. And we used Jupyter Colab, VS Studio, and it took around 1 to 2 minutes for the whole model to work and to code and give us a score. Now for the feature selection and engineering, we actually, it depended on different models, and we used both label encoder and we used ordinal encoder as well to change our categorical data into numerical. We had some imputation. We used some imputation methods that not all of them worked actually. We tried K-NN imputation. We tried iterative imputation, and for trying different hyperparameters. Sorry, but we decided on just sticking with the simple old mean and mode for numerical and categorical data, because it gave us the best score when we were trialing and error, because that's what we used. We did most of the time. We just trialing and error, different weights, different hyperparameters, different ways to try and fill the data and stuff like that. For the feature selection, we actually went with 2 strategies. We decided to go LOFO importance, and then we used and then we built on work of some of the people, the Kaggle contributors, We created all of their works. We thanked them for we actually managed to learn a lot from their work, and we used some of their code and some of their information to make our model even better. As you can see here, this is the variable importance plot. This is just some visualization for the data and how we chose the features. We can see the heat map as well. These were some of the features in the columns that we decided to use based on how they coordinated with the column we were looking for. Now for the training methods, it was mostly trial and error and using ensembling. We tried to apply Optuna to try and find the perfect parameters, but we decided to use predefined hyperparameters we found on an online source. We also settled on some weights that we experimented with manually, and we found that the optimal cross-validation was to be stratified with the k-fold, and went with it with all of our models, except for the simple logistic regression. This was after we studied it and we checked everything, and we saw that it didn't actually fit properly with it. Even though satisfied k-fold is scientifically the way to go. For some important and interesting findings, we had no prior knowledge in machine learning. We didn't actually take the course yet. When we met during the data engineering course. So our machine learning knowledge was a little to none. So we had to research and work hard to kind of get the model that we were doing, to know what we were doing and know how to actually get a higher score. And one of our concerns actually was how to deal with categorical data. We tried several methods. And we used target encoder, ordinal encoder, one-hot encoder, but we decided that label encoder was the one that we used the most because it gave us the best rewards. We also some of the models, they handled categorical data, but it felt more consistent to just use a numerical on all of the models that we used. For the simple model, again, we used the same columns that we saw that they were the best features, and then we used 2 CatBoost models in our final ensemble with 0.85 of our weights, and then we checked our AUC score to judge how our model was doing, and as we changed the k-folds, the weights, etc. The winning model gave us a mean AUC score of 0.808. Thank you. If anyone has any questions, I'm ready to answer them.
Thank you. That was outstanding. My first question actually is, we'd love to hear how your team met. Were you all in the same class, or did you meet through the Datathon? And do you all come from sort of a computer science or math or statistics or engineering background? And do you have the same set of skills, or do you have complementary skills?
Oh, so we met in a data engineering course. We heard about the competition there as well from our professor, Dr. Bush al-Hajawi. She actually helped us a lot through this competition. Me and Reem knew each other beforehand, and we kind of managed to get the other 2 guys with us, and all through the data engineering course. Yeah, we actually all have around the same skill level. We did come from a computer science background, since we are all studying data science and AI in the same university. So we kind of went through we have the same skill set. We kind of have all of the same things. Yeah.
Yeah, that's great. That's interesting. You mentioned you used CatBoost, XGBoost, LGBM, and logistic regression. Could you please explain to our audience what each of these models is and how they are different or similar from each other? And what research did you perform on each model?
Okay, so they're all gradient boosting libraries except for the logistic regression. Logistic regression is basically a statistical model used for binary classification problems. CatBoost is mostly known for its ordered boosting optimization. XBoost uses a more regularized formalization to control everything, while GBM actually handles critical data directly. So you could just give it critical data and it would work with it, but we chose to give it a numerical with the rest of the models. And for us researching, we just kind of trial and error and our way through this really. if we saw that a model did great, we'd add it to like the list of models that we're using. We'd see how it would work with other models, and then maybe delete it, add like change its weights, change the k-folds, stuff like that.
Yeah. Could you talk about, you're one of the few teams that used imputation, and not a lot of teams use that. Could you talk a little bit more about that?
Yes, so we tried different methods of imputation. We tried to use the KNN fold, the KNN, sorry, and we used multiple, like different stuff, iterative imputation as well. But we decided that like the mean and the mode were actually the ones that gave us the best results. Through our like through all submissions on Kaggle, they always gave us like the best score. So we just sticked with the simple mean and mode as they were the best in the results that we've seen.
Okay, that's good. Well, that's all the questions I have. Valerie or Maggie, do you have any?
Great. So if you had more time in this competition, what would you do if you had more time to explore the Datathon? Would you do anything further?
We would probably go more through the machine learning, trying to see different models. Because as I said, the machine learning world is like really huge, and we were just starting in it. So I feel like us going in, we would have, if we had more time, we would look into more models, into more trying to like fix and optimize our models that we used into the best that we can.
Wonderful.
That's great. Well, thank you very much.
Thank you.
Thank you. Thank you. It's wonderful to have you in our competition. Thank you so much. And to the rest of your team as well.
Thank you guys for this
Congratulations on it.
opportunity. Thank you.
Great. Okay, let's see. Next, we have, second. Oh, I can't do that. All right, so next up, we have the first place team who will present from Nigeria. Fatima Ujunwa, she will present on behalf of her team findings. So I'll bring her up here, and we are over to you, Fatima. Go for it.
Yeah, hi everyone. I'm Ujunwa Fatima, and my teammate is Ade Tomiwa. Sorry, next slide, sorry. Okay. Okay.
Oh.
Yeah, okay. Yeah, background, yeah. So I have like a purely tech background. I have a bachelor's degree in computer engineering, and then I'm currently enrolled in a data analytics program. But in between, I've like enrolled in like short programs, boot camps, data mentorship programs. And then I also have like a little bit of experience from like other platforms like Zindi. So I think that kind of helped me with this competition. So yeah, yeah. So for our training methods, we practically use like a stacking based learner. We use CAD boost and we use extreme gradient boost. And then we use like a meta model, which was like a logistic regression model. For our important features, we found out to be breast cancer diagnosis description, metastatic breast cancer code, patient age, BMI, and then we found pollutant variables to also be very important as well. For our tools, we use pandas, we use extreme gradient boost, CAD boost, and we use sklearn. We also use Jupyter Notebook. We also found that the model training took about 8 minutes on Kaggle CPU. Yeah, so next slide. So for the future engineering and selection, this was a very crucial part for us because we're trying to get rid of some columns, and the decision was made. We got rid of the columns by basically getting rid of zip code level features, practically features that did not exactly help us to distinguish between patients in a particular zip code, right? So we got rid of those features as first, and then we built our baseline model with that, right? For our categorical models, for our categorical features, we practically use one hot encoding. And that decision was made because we didn't want to use target encoding because we thought it was going to introduce like a leakage, right? Label encoding, we tried that, but I think one hot encoding kind of performed better for us in encoding, right? So can I go next slide, please? So other things we did, we also created new features from our pollutant variables like NO2 and ozone. We created features from metastatic breast code cancer feature. We also tried to like include other zip code level features to see if it will improve our accuracy, but it did not. Yeah, so we moved ahead. Then for our missing values, we did not impute because we're trying to, we're trying to leverage, we're trying to make use of like quality data, right? This is a classification-based problem, and having like quality data and quality features was very important for us. So as a result of that, we tried not to introduce bias. And so we did not impute, we just used like a cat boost and extreme gradient boost to, just try not to introduce bias, right? So yeah. So yeah, for variable importance plots, we found the breast cancer description for, female unspecified to be the most important. And then we can see other demographic features as well. You can also see BMI and all of that. Sorry, next slide, please. Yeah, so like this is an interesting plot because we found that for BMI greater than or equal to 50, we found that it was very easy to diagnose for BMIs like that. While on the other spectrum, BMIs less than that was quite harder to diagnose within the 90 days period. Yeah. So yeah, this is also like this is another interesting plot on division. Well, they're not exactly clusters to find here, but we found it interesting because for each and every division, there were different values, right? So we just tried to include it there. And it was also part of the important features. It was part of the important feature, not the top 10, right? But it was part of the important features there. Sorry, next slide. Yeah, so like I said, for our training methods, we use stacking classifier. We use 2 cat boosts, and we use 1 extreme boost. We use 90% of the data to train, and then we use 10% of data to predict, right? And then like I said, we use a meta model, and then this was done for like 10 folds, right? And then after we did that for 10 folds, the average of that was basically what we used as the final values for our prediction. Yeah, so this was a very helpful, this was a very helpful step because usually we see that people just split into test and train, but we try to make this we try to introduce like a stratified k-fold to ensure that the model learns on different subsets of the data, right? So we found this to be really, really helpful. Sorry, next slide. Okay. Sorry, I didn't include it here, but one interesting thing about the data is that we found was that for most of the cases, right, the metastatic sites was basically on the lymph nodes, right? And that's very intuitive because we see that it's very easy to diagnose very easy to diagnose cancer that is on the lymph nodes, right? Because it's palpable, and then there's always like an enlarging, there's like a swelling there, right? So we found that to be very interesting. We didn't include it here, but that was something we found out recently. And then I think what set us apart from this competition was our feature selection, engineering, and the fact that we introduced like the stratified sampling approach as well. So yeah. For our simple model, we found that the breast cancer diagnosis discretion and metastatic cancer discretion was literally accounted for like 90 to 95% of the model's performance. Well, that's kind of the obvious features there, right? And then we also found out that cat boost was very, very effective because, it gave us 0.799 ROC. Yeah. So I think that's it.
That's outstanding. Really outstanding. I was really impressed by a lot of the research that you did. And I just had a few questions. Like I've asked others, how did your team meet? What do you have sort of complementary skills? And how are you helping each other grow? What are your growth plans? What's your direction? And how do you plan to help each other?
Okay, first of all, we met on the Kaggle discussion forum. So I practically put in the global finding team hashtag, and then I think he responded to me. Yeah, so that's how we met. Yeah.
Are your backgrounds very different or very complementary?
Oh yeah, he's actually a practicing pharmacist.
Oh,
Yeah, and also a machine learning engineer. Yeah. So yeah, yeah, and me, I'm practically like a computer engineer and data scientist. So yeah, different background.
what is the direction of your growth, and how do you see yourself growing in this field?
Um, honestly, like I see myself like engaging in a lot of competitions with him as well, because like I mean, I really enjoyed like working with him. So in future, I think we'll be participating more in lots of competitions. Yeah. So yeah. So thank you, Women in Data Science, for helping us meet.
That's one of the wonderful aspects of the Datathon is you meet people out from anywhere in the world who are interested in your particular, who have the same interests.
Yeah.
One thing I found very interesting was your feature engineering, which like you mentioned, and you showed you created a lot of unique features, and showing the combination of NO2, PM25, and ozone, and this feature is actually among the top 10. And among the winning models, this is unique. This is definitely unique. And could you talk a little bit more about the feature engineering, any research you did, any correlations about that, and any interesting things?
Oh yeah. So like I said, features with most of the most of the data points had metastatic sites in the leaf nodes, and those features have metastatic code of C77 like 3, right? So, and we also found that a lot of breast cancer cases have metastatic sites, and those metastatic sites have metastatic codes that have four digits long codes. Sorry, I don't know how to put that well, but like they had the length of they had the length of 4 digits, right? I don't know how to explain that in a way. Yeah. So as a result of that, like we created like a feature from that. We created like length of metastatic codes. So we clustered it and we made sure that because we saw that that was like an interesting thing to see that most of the breast cancer codes, their metastatic codes were just the string was just four digits long. I don't know if I'm explaining that right. I don't know if I'm explaining that right. But that was one feature we created. Another feature we created was, we tried to we saw the NLP. We did like an NLP. Well, we didn't exactly do that, right? We saw that on the discussion forum. Thank you, discussion forum. We saw on discussion forum. So we see that for sort of female, right, was a very predominant description, right? And so we created like a cluster from that. So, and that's interesting because it's very easy to diagnose breast cancer when you're a woman than when it's any other gender, right? So we created a feature from that. We also created a feature from the pollutant variables, and that was basically try and error because initially we dropped it because we dropped zip code level data, and naturally, if you're going to drop that, it means the pollutant variables are going to be dropped as well, right? Because for each zip code, they literally have the same level of NO2 and other pollutant features. But then we went back to try and see if we could salvage any other important features, and we found the pollutants variables to be important. I mean, that was practically trial and error. That especially the pollutant variables, that was practically trial and error. Yeah. And then I think another feature we created was from I think that's all. I think that's all we created. Yeah, those 3 features. Yeah.
That's really interesting. Did you look at, I noticed that you had the mountain regions. Did you do any statistical visualizations of sort of the geography to help you develop your intuition, or any visualizations?
Okay, do you mean for the zip code?
As you're doing exploratory analysis, as you're fitting your models, what sort of statistical visualizations helped you?
So we did like heat maps, obviously, right?
Did.
We did heat maps, and then we kind of grouped as well. Like grouping helped. use like the group by as well. That helped. We didn't exactly include it in the notebook, but yeah, we did that as well.
Yeah.
And then we just did a little bit of like EDA. Yeah. But basically like correlation analysis helped a lot and like trying to know like the related features. Yeah.
What advice would you have to new contestants, people who start off, brand new, and they come in to the Datathon and and they have a brand new data set, and like you, they're exploring it. What would you what sort of advice would you give them?
Okay, so I would say research helps a lot. So like if you have like a data set, I think the first thing I would like to do is like research, just like get a little bit of like domain knowledge on what I'm doing. Yeah. So that helps a lot. And then when you do that, you kind of find out the important features. So you know which features to exactly work with. Right. I mean, it's not exactly obvious, but I mean, that's like a starting point, right? You kind of know the features to work with at first. And then over time you can drop the features that you think they're not relevant for that time, and then you can always go back and like try and see, like it's literally like a try and error thing afterwards. But like I think the first step is research, and then always try to like look at people's notebooks, like what people have done in the past. I think that's very helpful. That literally helps as well. And then discussion forum, like I said, we got a lot of things from the discussion forum, like the NLP EDA. And then we also even got like lots of like information and insights on the ICD codes, ICD-9, ICD-10. We got that from the discussion forum. So yeah, that's just look around. Yeah, that's what I would say.
Yeah, that's outstanding. I mean, you had a fantastic performance and to put in a lot of effort, getting your resources from different places and putting together a model. So I congratulate you on a fantastic performance and finding your teammate. And thank you for all the hard work, and thank you for your presentation. Valerie?
Yeah, this was great. I have no other questions. So thank you, Fatima, for the presentation. I want to acknowledge this comment from Diane. She says, it's so awesome that people have come together and made so many useful insights in such a short time. And I think that's really true with all of the winners here on the call. So thank you, Fatima, for all your hard work.
Thank you.
All right, next up, we have our second place team. Their team name is NGMI from France and Indonesia. I have to say what it means. You're not going to believe it. So NGMI stands for not gonna make it. And I think this is just such a great testament to the WiDS Datathon. Really, no matter where you are or your background, you can do it. And so Chidinma Obiagwu will present on behalf of your team, and I'll bring her up here. There you go. So over to you to present.
Hi, good evening, everyone. I don't know what time is it, who you're connected from. It's evening here, and I'm excited to be here today. And yes, so first, I think the pick of our slide is diversity is key, because we tried the key thing to us was trying out a lot of models compared to the traditional way of just trying 3 to 5 models to get your results. So I'll go first straight to the background of the team. So it's a team of 2. So Chidinma Obiagwu. I have kind of a technical background, but I'm currently working as a continuous improvement manager with Orange Business Services. And then my colleague, Iqbal, is from Indonesia. He also has a technical background. He's working with the Ministry of Finance as a data engineer, and he has also participated in a lot of competitions, and I think he's on the expert level in Kaggle. And so, yep. For the summary, like I said, why we said diversity is key because we use an XML of device models, not limited to logistic regression and GPT. And for us, we discovered that the breast cancer diagnosis code was the most important feature. And apart from several other data science libraries, we had to use like Pandas Kit. We also use category encoders. it was interesting for us because we had to use it to encode categorical features, and the average time to train the assemble on the full page should be 7 to 5 minutes. Yes. Okay, so for our feature selection, stroke engineering, first of all, we did a lot of encodings on the models, working from estimate encoders to category encoders. And we use this kind of encoders because apart from the cap boost that has its own built-in encoders, the estimate encoders helped the other libraries that we use. And so our top important features based on permutation, this is a feature we use just to rearrange the importance. And for us, we found, like others that has presented, the breast cancer diagnosis code to be the most important, followed by the metastatic cancer diagnosis code, and then the rest of it. So for us, for our feature selection, we did forward selection and backward selection. We know that this kind of, we chose this because of the number of variables we had. So we decided to use this kind for our feature selection. We noticed that the forward selection works more on the tree models. And by tree models, I mean the SG boost, cap boost, the light GBM, random forest, and several others. And the backward selection was done with other models like logistic regression, SVM, linear K, nearest neighbors, and all of that. And the interesting part was each of these models had optimal subsets of features. And yep. Okay, so for our training method, we used the 5-fold for cross-validation to retrieve our out-of-fold for the data set. And then for the assembling method, we'll first have to eliminate which model did not contribute to the assembly. Then we use Optima to find the optimal weight for each model. And yeah, like I said, each model had a completely unique subset of features. So this was quite interesting. And so this is just to show the forward selection. Sorry. No, did I miss the slide? Oh, sorry. Yeah, I was just saying that here. Oh, sorry. Thank you, Valerie. That each model had a completely unique subset of features. Okay, so to the next. It froze at a point. Okay, so for our important and interesting findings, like I said at the beginning, we use diverse models with completely unique subset of features. So instead of using the exact same for all the models, we created subsets to use on each of the models. What we found was that the air quality didn't seem to have any impact. It could be strange, but yeah, it didn't have any impact on the breast cancer diagnosis at all. And so with the patient location, these were some of the important findings we saw. Thank you. And so for us, we had the list, like the bottom list important feature. Most of them are almost completely to actual zero importance. So it was also helpful for us in reducing the number of features we had. Yes, please. So to our model, the cap boost gave us 97.5% of the score and this we did without any tuning. And then we had an optimate subset of features for the cap boost. These are the 4 features we had: patient age, PR type, the breast cancer diagnosis code, and the metastatic cancer diagnosis code, which were even among the first, like in the order of importance, they were among the first 10 important features. So this is just, not to go so technical, but this is just like an example of what the cap boost pipeline means. So we did the feature selection, imputed the categorical features, and then the cap classifier that help us do the model. And so yeah, thank you.
That's awesome, Ujunwa. It's a very impressive work. Thank you for all the hard work. And I have a few questions. First of all, you have a very unique background in terms of where you're from and what you're studying, background in data science and accounting. How did you leverage your different backgrounds? And that must be different ways of thinking, different ways of processing, different ways of gathering information. How did y'all bring the leverage your background for the competition?
Well, I would say that, like I said, Equal has participated in several data science related competitions that I think this helped him. And yes, amazingly, even though he has an accounting background, which is very linked to finances and the financial aspect, he had done a lot of short courses related to data science. So he kind of have quite some background in there. For me, I would say that it was more of a learning journey for me because I did a master's in big data and business analytics, but I have not had the opportunity to actually work in a role that is data science or orientated, or even participate in a data science competition. It's my first competition, I would say. So it was a huge learning opportunity for me, also to gain some practical knowledge to the theoretical things I know. So I would say it was really interesting, the mix. But yeah, and for me, I think someone from a financial background, since he's good with the numbers and statistics, would be a good a good fit for that. So yeah.
That's awesome. That's great. Well, you're one of the few teams that did forward and backward selection. Can you please talk about, your research, what differences in performance that you observed from these two approaches, and sort of your observations from this?
Okay, so for like many of us know about the forward selection, what it entails. First, I stated our reason for choosing to do this was the large number of variables or features that we have. And so first, for the forward selection, what we did was we checked the impact of each feature against each model, and then we found that, okay, the breast cancer diagnosis code gave the most positive impact, and we added it to our list, and we did this for the remaining features, and then that's how we're able to gain, at least we focused on like top 5 of these from the forward selection. And for the backward selection, we did the same thing. We just imputed these features, and then we checked for the one that has the most negative impact, and then we removed it from our list. We did it across the remaining features, and then we found out, okay, the metastatic first novel gave the most negative impact, and then we took it out. So basically, I think that we chose this aspect primarily because of the number of features.
Yeah, that's interesting. Personally, I find it interesting that you didn't find the polluting variables very high, but the other team, Fatima, found a combination variable as pretty high in importance. So I find that contrast quite interesting.
Yeah, it depended on just, well, I think also owing to the experience of Equal, he has had experience with different data competitions, so he kind of brought a lot of experience to the table. So that also could make the difference on how we approach the challenge.
Yes, that's interesting. You're one of the few teams that actually used Uptuna. Can you tell the audience what is this? And eventually you decided not to go with that. Why was that? And can you compare it to other frameworks you might have looked at?
I'm not sure I remember other frameworks, but really, basically, the whole idea of the Optuna was to check the optimal weight of the models we found, and this was why we used optimal in the first place, just to how can I? I'm not sure I could be in the best place to explain it, but we just use this to check for the optimal weight for each model, and then from this weight we selected from the results we got based on the weight.
That's great. That's great. A question is, how do you anticipate being involved in the WiDS community in the future in competitions? You seem to have learned a lot. Would you, will you be involved? Will you, do interesting things, post your models? Do you anticipate being involved in the community in the future?
Oh, definitely. So for me, it was twofold. First, it was a women in data science competition. So it was kind of like comfortable ground, seeing other women excelling in this field. And so for me, also meeting people, because I mean, Indonesia, I have never been there, but being able to collaborate and meet other people who are also not just participating in competition, but actually doing a lot with the research, because apart from the models and all we did, I benefited from the other interesting resources that we had on the Kaggle platform. So yeah, I really look forward. I said to myself that, I mean, I have been missing not participating in competitions, because I had always had the notion that these competitions were for someone who was like very skilled or technical, or have to have a level of expertise to participate. Or I had a different feel from participating in this. So yeah, I look forward to being
What would you
more.
say to a newcomer now that you've been through one round of the competition?
Yeah, I would just say confidently bring whatever level of knowledge you have to partake, because I think you benefit more from participating than just trying to evaluate your own skills by yourself. And the win-win is, even if your model don't get selected or you don't win, you've learned a lot of things on the journey, and so you have improved. So not getting the key prize is not just the winning thing. Like I said, the name of our team was not going to make it. We didn't think we were going to make it, but the whole idea was to enjoy the competition and learn from it.
That's truly outstanding. We love to hear this. Our background, we do a lot to bring together competition and to provide these resources to you, and to also build this community. So we are looking forward to hearing from people like yourself, coming to the competition brand new, using the resources, learning so much, and then giving back to the community. So it's a really outstanding performance. Congratulations, and thank you for an excellent presentation.
Thank you so much. Thank you, Valerie.
Thank you for your participation. Excellent job for you. All right, next up, we have the third place team, PAX2M from Bengaluru, India, and Maunvi Potapati will present on behalf of her team. I'll bring up Maunvi right now and hand it over to you. Go for it.
Yeah. Hi, everyone. Good morning. Good evening to all the attendees. So it's really a great honor to be here, and I am very much thrilled to have this opportunity to share our journey and experience with WiDS. So yeah, you can go on to the next slide. Next. Yeah, so this is our agenda. Okay, I will follow the standard template. So I'll start off with our collective backgrounds. So we are all fresh graduates. It's been only around 8 months out of college, and we are now working at Wells Fargo. So we are relatively very new to the professional world. We belong to the same sub-LOB. So that's how, we've through the shared workspace is how we first connected, and seeing our fellow colleagues participate in WiDS kind of sparked a motivation for us to join the competition. And pertaining to our academic backgrounds, I am a computer science graduate, and I predominantly work with UI development, and I have worked with a few Python related projects for a handful of projects related to Flask and OpenCV projects for my college assignments. And Arnav's computer science grad too, and his work primarily involved front-end projects. And here at Wells, he's been associated with backend development in using Java. Next slide, please. Coming to Pranav is also a computer science grad, much like myself and Arnav are, and he's the one among us with a foundational understanding of ML and data science, and compared to the rest of us. And his expertise lies with Java backend development here at Wells Fargo. And finally, Merin holds a degree in electronics and communication engineering, and she too worked with web dev during college. And she's got a little bit of experience here at Wells Fargo due to her exposure on ML during her summer internship. And currently, she is a full stack developer here. So before I move on, I just wanted to answer the most asked question to our team. That is the meaning of our team name, PAX2M. So it's a very simple acronym of the starting letters of all our names. So P for Pranav, A for Arnav, and X2M represents the two females in our team, Maunvi and Merin. So just wanted to share the backstory behind the magic word. So moving on. So to crack this problem at hand, from a very high level overview, we've used the adaboost boosting algorithm complemented by CV for hyperparameter optimization. So we've used the following features in our model. So, and we've utilized a Python ecosystem with the standard data science modules like NumPy, Pandas, and scikit-learn in a Jupyter Notebook environment. And we were lucky that we've got a relatively shorter model runtime that is around 3 minutes. So which really enabled us with rapid iterations and refinements, and helped us really try quite many permutations and combinations. Next slide, please. So as a team, we are really very new to the ML domain. And in fact, it was only for this competition that most of us even created a Kaggle account for the first time, and even writing code in Python. So from a beginner standpoint, we were really engaged in some extensive experimentation. We've tried quite some models and some experimentation with the hyperparameter tuning as well. So our exploration spanned across utilizing AutoML tools like Teapot to employing the most fundamental classifiers like naive Bayes, random forest, and different boosting algorithms like adaboost, catboost, and XGBoost. So we've also ventured into SVCs and neural network, got our hands dirty with neural networks as well. So all of this was to understand, to grab their capabilities with the predictive task at hand. So post this, with respect to the hyperparameter tuning, we've experimented with multiple parameters like pre-depths, learning rates, and so on. And we've also not only used the model straightforwardly, but we've also tried to ensemble different models for better predictions proportional to the performance of each of the models for generalization. And we've used techniques such as weighted averaging and stacking. So moving on. Next slide, please. Yeah. So for feature selection, we've used the following 7 features based on our evaluation on the relevance against the target at hand and what was their impact on the predictive task. So we've tried to plot the impact of each of the features against the target, apart from like just taking inspiration from a whole lot of Kaggle discussion forums, which is really, it really formed a good base for the beginners that we are. So our analysis revealed that the diagnosis codes, patient demographics, and insurance information are the ones that emerged as a pivotal indicator. So reflecting how key the patient age and demographics are for this prediction challenge. And we have employed some straightforward feature engineering techniques to transform and enrich our data set. So most of the features that you see we've narrowed down to were just categorical, and hence it was crucial for us to pay focus on the encoding strategy. Though we tried multiple encoding methods like one-hot encoding, label encoding, but we finally went on with ordinal encoding and to convert our categorical variables into numerical representation, that is to make it suitable for our modeling. And also because of the nature of this encoder, which is really good with preserving the ordinal relationship which was needed for the diagnosis codes. And moving on. Yeah. So finally coming to our winning approach, we've chosen the Adabos classifier as our primary algorithm, leveraging its ensembling learning capabilities and its adaptability to complex data sets. So to ensure the model's reliability and generalizability, we adopted a cross-validation strategy as well. So we've employed the K-fold cross-validation, and that's how we've effectively made sure that we assess the model's performance against multiple iterations, and that's how we guarded against overfitting and bias too. And it was through GridSearch CV that we've systematically explored, a whole lot of hyperparameter combinations, and that's how we've optimized the model settings to maximize the chosen evaluation metric, that is the AUC scoring. And our approach was heavily iterative with continuous refinement based on the evaluation results on the leaderboard. So this was what we have done. So you might, while our techniques might seem like quite straightforward, they represent a significant learning experience for all the beginners that we are. Like, we don't have any prior hands-on experience in this field. So this challenge, every step of the way, our journey was really exciting, and we did really try to take every opportunity to learn and improve. So this is it from my end. Yep.
That's really outstanding, Manavi. That was really well done. It's really exciting for me to hear, your different approaches. What I'm fascinated by is that you're all in a corporate environment, right? And you're sort of, this is your first year, you out of school, right? And you come from different backgrounds. One is, from computer science to engineering. I mean, could you tell us how that all came together? I mean, did the computer science background help you in doing all these statistical problems, or did the engineering sort of thinking, did that help you? Or, was it, just walk us through your mental process.
Yeah, thanks for asking that. So all of us, are currently and generally tasked with work that is primarily revolving around full stack projects. But in spite of that, we continuously had like a certain like quite a few internal sessions in Wells Fargo. So as part of the special interest group sessions, where people used to teach us about ML, to leverage ML and other domains. But we used to attend quite a lot of those sessions, but we never really got the opportunity to have a hands-on experience. So, and when we got to know that our colleagues were participating in something called as a WIDS, we thought, just why not try this? So that's how I think we were just really eager to try something new, and I think a new domain, and that's how we decided to give this competition a try. And coming to our previous skills set, how it supported us, and I think Pranav had, amongst us, it was Pranav who had an initial understanding. So although we were individually exploring so many things, I think he kept us grounded and to have a base solution. And Arnav was the one who was really into exploring the unknown always. So he was the one to help us exploring new tools like Teapot and so on. So, and apart from that, coding in Python was not at all challenging for any one of us. So that's something that's coming from the prior experience. So for us as software engineers, we code every day, right? So that wasn't big of a challenge. So yeah, this is all very new and exciting, and so much of learning throughout.
That's great. It's actually very interesting for us to hear that you had corporate support. And that's very unique. I mean, usually our audience is, graduate students or undergraduates or various students who are doing this as a part of the course curriculum. So it's very nice for us to hear that you actually had corporate support and you all got together in a corporate environment to sort of take the next step. And and that you were immersed and you learned a lot. So that's really wonderful for us to hear. My question, actually, I also have about, how your team approached it. That you had the widest set of models, amongst a lot of the teams. You definitely did a lot of exploration, and no doubt about that. What were your observations of the relative performance of each of the models? Did you think that the models sort of clustered together, and there was a sort of a standout model? And also, you're one of the few teams that used adaptive boosting. Cat boosting seems to be the kind of the flavor of the day. So, what are sort of your observations from that work?
Oh, yeah. So as I did mention before, like we did really try quite some models and we were more inclined towards like what you said right now, the flavor of the day cat boost. So we were also inclined towards that, which is, inherently the model that is supposed to work best with the categorical values. So it, as it got the inbuilt system to deal with, such values. But I think it was just general exploration that we found Adaboo's performance was, performing better because of its generalization and I guess how robust it is towards noise and how it focuses on misclassifications. And we did really try to ensemble it with XGBoost and cat boost proportional to their performances. We had a few submissions on them, but ultimately it was the AdaBoost one which came out as a standout model. And post knowing that that was the winning solution, we just looked up a few research papers and we just got to know that AdaBoost is lesser susceptible to overfitting, and it also has a reduced sensitivity towards hyperparameters. So all of this, thanks to AdaBoost, it was our winning solution. So yeah.
That's awesome. That's really wonderful. And also your team is the only team that experimented with Teapot. And could you please tell the audience what that is and what your experiences are or what your challenges are from it?
Yeah, definitely. So Teapot stands for a tree-based pipeline or optimization tool. So it is an automated ML tool. So its input is a data set and it generates a suggested ML pipeline for the data set that you provide. And since we're beginners, we were just Googling on understanding how to, select a model and select an appropriate model. And, how we just wanted to have a base initial model. And that's how we stumbled across Teapot. And I guess it took around 3 hours to give us a very basic ML pipeline. It suggests everything like from the pre-processing techniques, encoding, feature selection, model training, hyperparameter tuning, and it evaluates against the metric that you chose. So all of this we did try, but it just gave us a very basic base model to work upon. So the accuracy was less, but it was, it was a good start. But yeah, it's a tool that it's worth exploring.
That's awesome. That's outstanding. Do you have any sort of final thoughts or advice to, for newcomers or people who started doing this the very first time? Any thoughts?
Yeah, so this is our inaugural victory. We were really not expecting this, and all we wanted to have was just a submission. And we're also new to the domain. And all I would say to anyone that is starting out, yeah, the first steps are the most difficult ones. So once you just try to get your hands dirty, try a few solutions here and there. And I know for a fact that Kaggle community is just the best, and it's so helping, and irrespective of the skill, you can just ask any questions, shoot any questions, and you will find many public notebooks to have a base start with, and you can just give a honest try, and you never know where it can take you.
That's fantastic. It's really wonderful for us to hear this and to hear your fantastic performance and a lot of hard work. So congratulations to your team and congratulations to each and every one of you. And also, it's fantastic you guys work together with all your work pressures, you were able to work through the competition and come out and you learned a lot. So that's really wonderful. Thank you for participating and thank you for your presentation. Valerie, any questions?
Yeah,
Thank
thank you, Andy. This was really wonderful to hear from you and your team. So thank you again for your participation, and we hope that you stay involved in the WiDS community.
Definitely, I'm looking forward to.
Thank you.
Take care.
Thank you.
Okay, next up, we have the top first timer of the WiDS Datathon team. Their team name is the Synergistic Solvers from Riyadh, Saudi Arabia. And Saima Jabin, who is also a WiDS ambassador, will present on behalf of her and her husband, who participated together in the challenge. So I'll bring up Saima right now and hand it over to you. So go for it whenever you're ready.
Thank you very much, Valerie, and good evening, everyone. Yes, this is Saima Jabin from Riyadh, Saudi Arabia, and I am affiliated with AI Center Al Faisal University. So thank you for providing this amazing opportunity and to get more involved in this platform. Yes, we were the first timer team here in this competition, and in order to solve this challenge, of course, it was a bit different journey, which I will let you know. As you had mentioned, my husband as a team member of mine. Then before that, I was the first ambassador here in Riyadh for the WiDS Women in Data Science platform. So I was not much into the activities for this task, but I am grateful and I give its credit to our seasonal Riyadh WiDS ambassador, Dr. Arij. She had asked me to hold a workshop in my university there for the other peers or the interested ones or for the students. And it was 27th of February. So I was very late into it. And I had to conduct that workshop, and that it is best to learn if you teach first. So in order to execute the workshop, of course, I have to go through all the description, all the information about this challenge, and so on. So that was the experience from where we also had participated as a team after her advice, and we did it. I did my PhD from Politecnico di Torino, Italy, and my husband also did his PhD from the same university, but from another department. But the major for both of us was data science. So that's why the team name, you can see that it is Synergistic solvers, because we cooperate with each other, we complement each other. So this way, we formed a team in order to solve this challenge as well, whether just for the sake of curiosity and just to exercise our data science skills. And it really gave us confidence. So on the very first try, when we made use of the random forest, then when it gave 76% of accuracy just for doing little bit of feature engineering, then it was amazing to see that, okay, we are not far behind than the other competitors who were really involved since January when this competition got started. But this was all about it. Okay. So the way we solve this challenge, it actually first definitely is with the feature engineering, in which we had figured out the important features. We also had augmented augmented the data by splitting the features and with the one-hot encoding, which I will discuss. And then the ensemble classification gave us the best results. And we used, of course, Python language, the most favorite one, and also we have been using it since quite a long time. And in order to train the model and for execution of all this solution, it took us 1 hour and 45 minutes to run it as a whole, because we were not having GPU, so it was on the simple CPUs. Okay, so for feature selection and feature engineering, first of all, we combined, both the test data set and the training data set, which was provided by your platform and the Giggle. And then why we did so, because when we were experimenting with the data, then we had analyzed during EDA process, during our exploratory data analysis, that some values of some columns, some features were not there in the training data, but they were in the testing data. So for one-hot encoding, which we aim to use, for that, of course, it could be troublesome. So that's why we combined both kind of data sets for one-hot encoding, so that we could have consistency in our data. And then we combined those separated data again. We separated that combined data again into training and test data. And another thing which we made in our features engineering, we dropped the gender-based attribute named as patient gender, because we manually analyzed as well as through programming, we came to know that there was just one count of the value for this feature that was only female. So it was not contributing, much information to the target variable. So that's why we had dropped it. And also, there were two other attributes with the name female and male, and we also had dropped them because they were not having any impact. And then we also checked the count of the missing values in the features, and we saw that the metastatic first novel treatment and metastatic first novel treatment type, and they both have the highest percentage of missing values, around 99.8 or like this. And of course, the machine learning techniques are not good to afford such huge number of missing values. So we dropped them, and of course we saw then the improvement in the performance. And some other features were also having around 63 or 65% missing values, but when we dropped those features, then it was not of worth, so we retained them. So only we dropped the mentioned ones. Okay, so there was another feature with the name breast cancer diagnosis description, and here the textual information was given as values for this feature. And here we had noticed the significant words occurring in this information. So here we applied natural language processing, which we were already familiar with it. Our most of the work is related to deal with the textual content, so we had splitted this textual text, this textual content into words. We removed stop words from these textual phrases for the description, and then we returned only the significant ones. And of course, then there are different mechanisms to encode, the information. And there is also, previously we had made use of TF, IDF, term frequency, inverse document frequency, but here we made use of one hot encoding. So, and this way, this the NLP process, after removing the stop words and retaining the significant words, we performed one hot encoding, which resulted into many extra features, as extra columns. And there, through one hot encoding, we got their presence, their absence in the data set. So, of course, this was the one hot encoding was also used for other categorical attributes. And for the numeric attributes, either we could go for the normalization or standardization, which we prefer to go for standardization as it was giving us good results. And also because we were having very limited time, so we could not experiment a lot. So we were just going ahead, whatever we were getting our good results with. So we performed standardization for the numeric attributes or to scale, to bring the different values on different scales into the similar ones. And then the patient zip3 feature, it is found important because when we excluded it, then it reduced the performance. But overall, there was another feature which was contributing a lot, and we call it utmost importance in our adopted methodology, that was patient age. So in the next slide, we had drawn the importance of the top 10 variable features. Although initially, as your provided data was having 83 features for the training, and for the test data set, there were 82 because it was lacking the target variable. But when we performed this feature engineering, then it resulted around 963 features. So here we are showing just top 10 features because it's not possible to draw the importance of all. So you can see the patient age is the utmost of importance, and then the malignant word, and then the female malignant attribute, the female attribute. Now this female is not the female attribute which we dropped, I had discussed previously. This female attribute is in the result of splitting that description, a feature which I had discussed in previous slide using NLP techniques. So there again, the female attribute and the male also, they came as additional features. Okay, so this was about the features. And the correlation, yes, here you can see the correlation of these features: patient age, malignant, female, neoplasm. These are the correlations between target variables and these important features. And the negative values, they are showing the negative correlation, but of course it is still a relationship because the value of one affects inversely to the other target variable and so on. Okay, but the limitation or the drawback of our approach is that we performed a feature selection by hit and trial method. Means in order to find the importance of the features. If some feature was not giving us better performance, then we were not considering it, and the one which was giving us good accuracy, then we were following it and so on. So this way we made selection of our feature, which is not an ideal approach, of course. If we could have time, then we would prefer to go for a chi-square test or the Fisher score, which are the statistical tests, to better select the features. Okay, and in the previous slide, there is a link which I want to mention here. We would like to give it a credit of our baseline work because when we entered into the competition, then we found this WiDS Datathon challenge, WiDS Datathon as a whole, as a very nice platform in order to learn from each other, So there they had provided their work, and we also got ideas, okay, how they are going with feature engineering and then for the classification. And then we took help from their code as well, and then we built on our own ideas. So for example, they had made use of the ensemble classifiers, but when we also added SVM, sport vector machines, then it increased our results. So this was the way that we also learned from this community. Okay, the next slide. Yes, for the training methods, yeah, we had tried from the beginning, we had tried single classifiers and then like a random forest and the other which we assembled later. And also we had tried, and specifically my team member, he had tried deep learning. And with fully connected and deep learning, and also with dropout layers because when it was having showing overfitting, but they didn't give us the best results. Random forest as well as the deep learning, there was overfitting when we were using these models, and the performance was around 77%. So then we had made use of ensemble classification, where the mentioned classifiers like SPM, XGBoost, CatBoost, OtherBoost, LGBM, and logistic regression were the base classifiers, while as a meta classifier, we had made use of XGBoost. And then, of course, there is also different ways to assemble the classifiers. We made use of the stacking process, stacking procedure to assemble these classifiers. And in order to train the individual classifiers or base models, can you go to the next slide? Yeah, okay, here is now, yeah. Okay, so yes. Yeah. Okay. So yes. For the important and interesting findings for our solution is that we believe that the unique set of features and handling the missing values, it made us different and gave us good results. And then also because we noticed that some Kaglers they were focusing either only on categorical attributes, and some were not handling missing values properly, which we focused on, and that's why we got some good results. And also, as I already mentioned, that we had also used SVM to assemble the classifiers, and then dropping gender-based attributes and the ones with missing values in big percentage, it also contributed, in the good performance of our classifier. So for the simple model means if we were not using these many kind of things, then we noticed that if only we could consider categorical attributes, then they are enough if we are going to use a label encoder, because our problem was the binary classification problem. So label encoder would be enough to use to get the sufficient accuracy just by making use of cat boost classifier, because we had tried it and it gave us around 78% accuracy. But with the additional one, of course, we had proposed this solution. And for the private score, it was our model showed 0.799, and for the one with the hidden, it was 0.802. So this way, thank you very much for nominating us as first timer winner.
That's awesome, Saima. Really impressive performance. Thank you very much for a very detailed, presentation, kind of walking through your approach. I can tell that you come from an academic background and that you are involved in teaching, and that you're very dedicated towards your teaching profession and your research. So I want to thank you for your contributions to the WiDS community. For being an ambassador, and that means a lot to us, and we are very grateful for your hard work and for the sincerity and the really the dedication with which you contribute to our community, and so we're really grateful for that.
Thank you so much.
And I don't want to go too long, but and we hope that you will have more detailed sort of more WiDS seminars in the future where you can talk about things in more detail. And really quickly, a question for me is you're one of the few teams that used NLP extensively.
Yeah.
So I want to acknowledge that and say if you have any sort of quick thoughts for people, for the community, or maybe resources on how they can leverage NLP to expand their feature set, I'd love any really quick pointers that you might have.
Yeah, because first when we analyze the data, of course, then we have to pay attention on the data, on the features themselves. If they are not just the values, if we discuss the categorical ones, then if they are not just the single words like male, female, gender-based or others, if they have, the phrases or the textual content more than one words, then they can perform NLP, and they should pay attention that how they can get rid of unnecessary information. Sometimes redundant information also doesn't contribute a lot in the prediction kind of problems. So they can perform NLP in that, and like we perform encoding, so that can also give them the better results. And of course they can also accept the such kind of competitions and challenges, like now after this participation, I really got more interested into such things, and I have also joined another platform related with you. I am not sure whether it is well connected, but I had joined Women's in Big Data. So I'm yet to explore that platform. So it really enriches, the knowledge and also the curiosity which you develop in yourself, and then you learn, you keep learning, and this way you can experiment with the data and you get more confidence.
Yeah, that's really outstanding. Thank you for your advice. And thank you for your contribution. And we look forward to seeing you again and again at WiDS.
Yeah, sure. My pleasure.
And
thank you very much.
Thank you. In the future.
It was really great to hear from you. I love the point you said that the best way to learn is to teach first. And that's such a great insight for those who are just starting. So wonderful to have you in the WiDS community, Saima. Thank you so much.
Thank you very much.
Thank you. Thank you very much.
Thank you.
All right, last and certainly not least, we have the top high school team, Maggie Gu. She is located here in the United States in Ohio, and she participated solo in the Datathon. I have to just acknowledge that it takes a lot of courage and hard work to work through the challenge solo, and so we are really inspired by your accomplishment, Maggie. And Maggie will present her findings and solutions for the challenge. So I'll bring up Maggie here, and over to you whenever you're ready, Maggie.
Awesome. So as Valerie said, I'm Maggie, and I'll be presenting my solution. For my background, I'm currently a high school senior, so I don't have too much professional or academic experience, but I did take a few courses like AP Computer Science Principles and AP Statistics. I'm currently taking, as well as Coursera's Google Data Analytics course, which I feel like helped me a lot with this competition. For a summary, The training method I used mainly was stratified k-fold cross-validation, and the most important features I summarized were data preprocessing, encoding categorical variables, selecting columns, splitting data, model training, and generating submission. And the tools I used were a CatBoost classifier model, which I used for binary classification, an ordinal encoder to encode categorical variables, and the patient zip3 column. And the length of training for my model was 28 seconds. For feature selection and engineering, this is a graph of the variable importance plot, where you can see the breast cancer diagnosis code was definitely by far the most important feature for my submission model. For the important feature transformations, imputation, which was where missing values in both numerical and categorical columns are inputted, and the numerical columns are inputted using, the median, while categorical columns are inputted using the model. And ordinal encoding, where categorical variables, including the patient zip3, are encoded using ordinal encoding, and this transformation assigns integer values to categories, which preserves the ordinal relationship if it's present in the data. Another feature I used was feature selection, where a subset of columns is selected for training the model based on importance or relevance, and this subset was stored in the calls variable, and it includes the listed features. And target encoding, where it wasn't explicitly mentioned, but the target variable diag period 90D might be considered as part of the feature transformation process, since the model predicts the probability of this target variable based on the provided features. And the partial plot of important feature number 1. So partial at the beginning of the plot, as the values of the feature increase, the predicted values of the target variable also increase. So this indicates a positive association between the feature and the target variable, and it suggests that higher values of the feature are associated with higher values of the target. And then there's a sort of plateau where it indicates that the feature has reached a point of diminishing returns, or where additional increases in the feature has little to no effect on the target variable. And then there was a drop at the end, which shows a downward trend, and it suggests that higher values of the feature are associated with lower values of the target variable beyond a certain threshold. And it could indicate that excessively high values of the feature might be detrimental to the outcome. For the second partial dependence plot, this pattern was definitely a lot more complex than the other one, since there are a lot more fluctuations. So it suggests more of a nuanced and potentially nonlinear relationship between this feature and the target variable. So there's a short plateau at the beginning, which indicates that there's initially little to no change in the predicted values of the target variable as the values of the feature increases. And then it's followed by an initial drop, which indicates that increasing the values of the feature is associated with a decrease in the predicted values of the target variable. So this suggests more of an inverse relationship. And then there's a slow increase following the initial drop, which indicates that beyond a certain point, increasing the values of the feature starts to have a positive effect on the predicted values of the target variable. And this suggests that the relationship becomes more positive after a certain threshold. And then there's a drastic drop where the indicates that further increases in the feature leads to a sharp decrease in the predicted values of the target variable, and it might suggest a critical point beyond which the feature has detrimental effect on the target variable. And then there's a short plateau where the predicted values of the target variable remain relatively stable despite further increases, and it suggests that there's a short range where the feature has little to no effect on the target variable, similar to the initial plateau. And then lastly, there's a drastic increase where indicates that further increases in the feature beyond the saturation point starts to have a significant positive effect on the predicted values of the target variable. And this might suggest another critical point or threshold where the feature becomes highly influential. For training methods, I mainly use stratified k-fold cross-validation, which is where the data set is divided into k equal sized folds while ensuring that the proportion of classes in each fold is approximately the same as the original data set, and this helps in handling class imbalance if it's present in the target variable. So in each iteration of the cross-validation loop, one fold is used as the validation set, and the model is trained on the remaining k-1 folds. And this process is repeated k times, with each fold serving as the validation set exactly once, so the model is trained and evaluated on different subsets of the data. And stratified k-fold cross-validation helps in obtaining a more robust estimate of the model's performance and ensures that the model generalizes well to unseen data. And another training method that I used was model training and evaluation, where inside the cross-validation loop, a cat-boost classifier model was initialized with specified parameters, and the model was trained on the training data split into k-1 folds and evaluated on the validation data. And the use best model equals true parameter ensures that the model with the best performance on the validation set is selected and retained. So the AUC score is calculated for each fold, providing a measure of the model's performance on each validation set. Lastly, I used model averaging. Model averaging, where the AUC score obtained from each fold are averaged to compute the overall performance of the model, and this average AUC score gives an estimate of how well the model is expected to perform on unseen data. So for ensembling, I did not choose the ensemble. For important and interesting findings, this is a ROC graph, or an ROC curve, which is a receiver operating characteristic curve, and plotting this helps evaluate the performance of the model, in this case, the cat-boost classifier, across different thresholds, and it helps with assessing its ability to discriminate between positive and negative instances. Next, I have a correlation heat map, which is a correlation heat map of the numerical features. So the solid red diagonal line you see is because each variable is... Oh, I don't know if my presentation from this one is updated, because I changed it so it's a bit clearer. Sorry. But I think in the changed presentation, you can see it more clearly, but there's like a solid red diagonal line that goes through the middle, and that's because each variable is on both the x and y axes. So the correlation between a variable and itself would be 1.0. And the negative correlation values on a heat map indicate like an inverse relationship between the corresponding pairs of variables, and the positive correlation values, which would be the red ones, on a heat map indicate a direct or positive relationship between the corresponding pairs of variables. So a heat map like this one can help identify relationships between different features and potentially redundant features. For the simple model, I'm not sure if I interpreted this correctly, but the subset of features that would get 90 to 95% of my final performance was just the data for breast cancer diagnosis code and patient age. And when I put this in, the performance score of the simplified model was about 0.816. I think that's all.
Thank you, Maggie. That is really impressive for a high school student to have come this far in your own study and in your own exploration, and to have done so much research and so much work. I want to congratulate you on your performance and your hard work. And I have to ask you a couple of questions. That image is the correlation structure is one of my favorite images. It's what I do, right? It's very well done. Can you talk a little bit about it? And did you, what did you use, Python or R? And also, did you consider using sort of multivariate analysis as a background research? Did you look at different multivariate approaches? And if you had more time, would you have done that? So I have to ask you these questions.
I'm sorry, the presentation, I recently added a screenshot of the code to it. So
we'll be sure to update it if you want.
Yeah.
Okay.
No problem.
Sure.
Yeah. but it should be like right above the heat map. So I did use Python. Basically, I just copied, like I made a copy of my submission, and then I added a little section of code for like, here, let me look at it. So I just basically had it plot a heat map, like using Python, and it came up with the image. In the updated PowerPoint, it's like it's a lot more clear, so you can see
If you have it on your slide, if you want to pull it up for participants to see, it's really impressive. Oh, you're on your computer.
Yeah.
Yeah, we'll send it out after.
Yeah, we'll update it. Don't worry.
We'll update it.
I could try to.
That's all right. It's okay.
Send it out to everyone afterwards. It was such a great heat map.
Yeah.
Thank you. Yeah. For the other questions about if I considered like other multivariate approaches, I did consider like using exploratory data analysis, which like is kind of similar to the heat map. Like you can use scatter plots and pair plots or like correlation matrices, since the heat map is sort of like a correlation matrix. But like a correlation matrix would be more like a square matrix, and it displays like correlations between a set of variables in a data set. So the heat map is more of like a graphical representation of the data where the values are depicted as colors instead of their actual numbers. I mostly stuck to like more like visualization interpretation of like multivariate relationships using like heat maps or things like that. If I could, some other like multivariate analysis, like statistical tests that I would have done, I think you mentioned PCA. That would have been helpful, definitely, because it would have helped like reduce the complexity and help like make it more lower dimensional. So yeah.
That's awesome. I'm truly impressed that at your level of knowledge and confidence with which you're able to work through the data set, and there's some really complex questions and you're able to work through it and think through it. So that's really wonderful, and congratulations on an outstanding performance, and thank you for your participation and hard work, and we look forward to seeing you all in future competitions, and hope that you will be part of the WiDS community going forward.
Thank you, Maggie. And I want to ask you just one thing that one participant said that you mentioned a course that you took. What was that course? I think you mentioned it in the beginning.
So Coursera has a Google Data Analytics course, which I was taking actually. I'm part of like the Boba Talks Discord server for high schoolers, and they offer a lot of cool programs because they were giving away Google Grow scholarships. So I was able to like take the Coursera course for free thanks to that.
Wonderful.
That's wonderful. Thank you, Maggie.
Thank you.
Excellent job, Maggie. Congratulations.
Thank you.
Just want to, I just want to say that it's there's been tremendous hard work. Congratulations to all the teams for an outstanding performance. And as you can see, each of the teams pursued a very unique approach to modeling, and that's what is really remarkable. And that's what makes this competition so great. Is that we can learn from these different approaches to one problem, very concentrated problem, but everybody has a different approach, and we can learn from each other, and we can learn and grow together. So I invite you all to continue to be a part of this community, and we look forward to your contributions in the future. Thank you all, and I'll let Valerie take it from here.
Yeah. Maggie, would you like to say any few words at the end before I close this out?
Yes, I want to congratulate the winners and also let you know how important the WiDS community is to Kaggle. Many women say that they get intimidated by participating, but just the stories today show that you can make these cross global collaborations and achieve some amazing results. So we're excited. Thank you.
Yeah. Thank you everyone for participating. It's just been wonderful to hear from the winners. So thank you all. This is the first time we've done this as a panel. And so it's really inspiring to see all the solutions discussed. So I'll just close us out with a couple of final housekeeping items. Awesome. So, yeah, as I said, this concludes today's panel discussion. And on behalf of the WiDS Datathon and also the WiDS Workshop Committee, thank you to everyone who helps to create today's event. It really does take a village. So join us for the next WiDS Datathon on April 9th. During the next Datathon challenge, we are going to look at how climate patterns impact access to healthcare utilizing this Gilead's oncology data set. And so whether or not you participated in the first challenge or you didn't, you're more than welcome to join us in the next challenge, which will launch on April 9th. And today's panel was actually hosted as a part of the weekly WiDS Upskill Workshop series, which is really designed to upskill data scientists and aspiring data scientists all over the world. And so next week in our WiDS Workshop series, we are going to hear from Alina Ravelis, who will deliver the workshop Data Science Career Tips for Aspiring Women. And so I hope that is actually a great tie-in to what we just talked about today, and I hope that you'll join us next week for her workshop. And let us know what you thought of today's panel by filling out this short attendee survey. I dropped the link in the chat that you can use to take that. It'll only take about a minute. And additionally, if you are interested in delivering a WiDS workshop on a topic that you are really passionate about, either a technical data science topic or even a professional skill building topic, we invite you to become a WiDS workshop instructor and fill out a brief speaker application, which I also just dropped in the chat. And so thank you everyone for just joining us today. And we look forward to connecting with you next time on another WiDS Upskill workshop. We'll keep the Zoom open for a minute so you can capture those links and hope that you all have a great rest of your day.